Welcome to another physics class. If you are new to this channel, please try to like, share, and subscribe. So when I upload new video, you'll be able to get the notification. Thank you. And the topic before us is the continuation of what we have been doing before, that is uses of dimension. Under this number 1, we've given some examples, and we want to continue with the example today. For today, number 1, find the dimension and unit of electromotive force. Find the dimension and the unit of electromotive force. Don't forget the derived quantity in this question is electromotive force, EMF. And the formula for EMF is work done over quantity of charge. Now, don't forget our rules that we want to derive the dimension and the unit of any physical quantity which is derived. The first thing we need to do is to know the formula of that derived quantity. Once you know the formula, next is to look at the formula. If the quantity present in the formula are all derived, then you reduce to their fundamental level, like what I've written on the board now. Now, work, as usual, is what? Force multiplied by distance. And quantity of charge is current multiplied by time. Force is still derived. We need to reduce it. Force is equal to ma. Then that will be mad over it. A is still derived, which is acceleration. And the formula for acceleration is what? Velocity over time taken. That will be it. Now, from what we are creating now, velocity is still derived. We need to reduce it again. That will be displacement multiplied by distance over it. So from what I've written on the board now, you can now say that all the quantities here are fundamental. Then you can now write it one after the other and compare it with the fundamental quantity. So the present mass, displacement, current, time. Let's write it as mass. The dimension for mass is capital M. Displacement time, it will be related to length. The dimension for length is capital L. Time is there. Time. The dimension for time is capital T. While the last one that is there is current. And the dimension for current is capital I. Now, you can now say that from the series of fundamental quantities that we have here, these are the fundamental, the basic fundamental or basic quantity that they can be related to, that is mass, length, time, and current. Mass, capital M. Displacement, equivalent to length, capital L. Distance, also length. Time, capital T. Current, capital I. Now, to write the dimension of electromotive force now, it will now give us dimension of EMF. Then it will give us this one, capital M, L, L, that is displacement, distance. They will relate to length. Then capital I for current and T, T, T. To continue with this one, then we are going to have dimension of electromotive force will now give us M capital L square over I T Q. Finally, we are going to have for electromotive, that is M L square I raised to power minus 1. Don't forget rule of indices, T raised to power minus 3. That is the dimension of electromotive force. And don't forget this one again, that if you want to write dimension, it must be written in capital letter. That is why you can now say that once we compare with the fundamental quantity, then we change it to capital letters. Just to tell us that we have decided to write the dimension. And finally, this is the dimension of electromotive force. Now, if you can still remember what we done last, that what is dimension? That is the power to which the fundamental unit of mass, length, time, etc. must be raised to form physical quantity. You can now say that the power of M now will be 1. That of L, that is, if the question say what is the number of times that all these fundamental quantity occur. So for M will be equal to 1. That is the power to which mass will be raised. L will be equal to 2. I will be equal to minus 1. And T will be equal to minus 3. From there now, according to the question, we should write the dimension and the unit. So the basic unit now, basic unit of electromotive force, unit of EMF, then will be equal to kilogram for mass, meter square for length, per ampere per second cube. That's the basic unit of electromotive force. Now, number 2 question for today. Let's divide into 3 parts. A, find the dimension of Young modulus. B, to what power must mass, length, and time must be raised to form Young modulus. C, write the basic unit of Young modulus. Now, solution to this one. Don't forget our rules. that the derived quantity here is Young modulus. That's the symbol. And the formula is tensile stress over tensile strain. You can now say that both the quantity that constitute Young modulus are derived. Then we need to reduce them. Tensile stress is force over area. Strain is that divided by new length over original length. We continue. From there now, we can now say force is derived, area is derived. So you can now say F over A multiplied by L naught over E. Now, since force is derived, area also is derived, then that one will now be MA over length times breadth into L naught E. Acceleration is derived. So we need to reduce it. That will be mv L naught over lb a over t. There, velocity is still derived. So we need to reduce it. That will be md L naught over lb e t t. Now, from what is written on the board now, you can now say that all the quantities here are fundamental. If they are fundamental, then they will be related to a particular fundamental quantity. Let's take it one after the other. From here now, so you can now say that mass is for mass, displacement, length, that's L naught, length, breadth also length, extension also length, then tt. So to relate this one now, then we are going to have for the dimension of Young modulus now, dimension of Young modulus will now be equal to capital M for this one, displacement, capital L, length, another capital L over length again, capital L, breadth relate to length, capital L, extension or new length relate to length, capital L, then t. So from what is on the board now, then we are going to have, this one will go away, we are going to have m over lt square. Apply law of indices, then we are going to have m l raised to power minus 1 t raised to power minus 2. That is the dimension of Young modulus. Now, we've answered question A now. Question B now says, to what power must mass, length, and time must be raised to form Young modulus? So from what we've seen on the board now, this one will be equal to raised to power 1, this one raised to power minus 1, this one raised to power minus 2. Then the answer can now be m will be equal to 1, l will be equal to minus 1, and t will be equal to minus 2. To answer the final question, which is C. Write the basic unit of Young modulus. The basic unit now. Basic unit. That is the unit from this level that form the fundamental quantities of 8 basic units now. It will now be kilogram for mass, meter for length, and second for time. It will be kilogram per meter per second scale. Now, we can now see that from this, the first application or use now, that is to determine the dimension and the unit of physical quantity. We have enough examples under it. And this one will be the final example that we are going to give under this one now. So as I said, we have many derived quantities. So if you still have any question in getting the dimension and the unit of any derived quantity, you are free to send your question through the comment section. As I said earlier, don't forget to like, share, and subscribe for more notifications.